This is the lecture for Chapter 8.1. Chapter 8 has to do with sampling distributions. We'll talk about what that is. And so make sure you have your note sheet out, your 8.1 note sheets. Looks like that there. And so in this section 8.1, we'll be talking about the distribution of a sample mean. So what I'm looking at here is some definitions that we're going to be playing with. So I'll see if I can explain them. And then we'll do a little demonstration of what it looks like to create a sampling distribution. And so the definition is there, and you would don't have to write that down. You have that, but the sampling distribution, looking at that here, of a statistic, and again, that in our case, that's going to be a mean and then a proportion on the next section. Sampling distribution of a statistic is a probability distribution, which we learned in chapter 7 and 6. For all possible values of a statistic computed from a sample of size n. So we're going to end up conducting a sample from the population, getting a result, and then we're going to end up doing that multiple times, which we would then, in this case, this section is the sampling distribution of a sample mean. And so what we do is we take a sample from the population of a certain size n, and then we calculate the mean and standard deviation, and then we do that over and over and over again a certain number of times, and then we look at the mean of those distributions, of those samples. So we take a sample, calculate the mean and standard deviation, and then we go ahead and look at the distribution of all those values. Let's take a look at the steps it needs to conduct a sampling distribution. And again, these PowerPoints that I have here are online. So step 1, attain a simple random sample of size n. That's step 1. You would write that down. So we're going to do a sample of size n. Step 2, compute the sample mean. You get the value. We'd also do standard deviation, but sample mean. And then step 3 is assuming that we are sampling from a finite population. We just repeat the steps a certain amount of times. And after we do that, or the same sample size, we then have a sampling distribution. And so it's the idea of repeatedly kind of sampling a population. And so you wrote in those steps. So you've obtained those, you wrote those steps in place. And now let's go ahead and take a look at some sample data. In class, I'll do this and give you this information. This information comes from the survey we did like the first day of school, or the first day of class. I asked you to do some data, and I collected data. So I just picked a sample of 20 people. So let's just assume this is our, I got the number of siblings from 20 students from our class. I got that from the beginning of the school year. And so that's what those numbers are. So in class, I'll have you type that in. But for now, let's go ahead and look at that data. And so we have, let's assume this is the population of our class. Let's just assume it's 20 people. Okay, and here's the number of siblings, brothers and sisters, that we have in the class. What would the distribution, draw the distribution for the population? Again, we're assuming, in this case here, just got to make assume, we're assuming this is a population data. We're assuming this is a population data. So it's important. I know it's only 20 people. We're assuming this is the class population. Let's just assume it's 20 people. Population. Okay. We're assuming this is class population data. And so there's your numbers there. So what would the distribution look like? Well, we would go ahead and make a scatter plot of that, or not a scatter plot, we'd make a histogram. So what would that look like? Graph. I'm going to make a histogram of the data, of the sibling data. I'm going to overlay the normal curve to see what that data looks like. And so we'll end up having that value there. Can I put? No, let's get off of that. I was going to put a standard deviation, but to get the mean. So let's take a look at what this data looks like. And this is the distribution. This is what the distribution would look like right here. So what we have here is, here's the picture of the distribution of this population. Again, assuming this is the class population data. The mean number of siblings we have in the class is 3.2, brothers and sisters, standard deviation 1.705. Now what we want to do is, and so this is what we calculated here. What we want to do is the mean was 3.2 and the standard deviation is 1.7045. That's for the population. And so now what we want to do is draw the distribution of sample means for 10 samples of n equals 5. This is called the sampling distribution of the sample means. And so what we need to do is draw 10 samples of n equals 5. So we're going to let StatCrunch do that for us. There's an application that can do that, do sampling distributions. I'm going to use the sibling data that we have here from the data table. And we're going to calculate the mean. And so what we want to do here is run a simulation. So it's going to choose 10 samples from this here of samples size 5. Yeah, let me double check what we said here. We're going to do 10 samples of n equals 5. This is called the sampling distribution. So that's what we want to do. And so what we have here is, let's go ahead. So what's going to happen, the computer is going to randomly choose 5 people, calculate the mean and standard deviation for that. So let's do that 5 times. It's choosing, and you can see it's choosing from the population data here, getting different values. We're going to do that 10 times. So now we've done it 5 times. Let's do it 5 more times. Drawing samples from the population. It's 8, there's 9, and there is 10. And so you can see right here, here is the distribution right here. And so what we end up with when we take a sample of, 10 times of n equals 5, we get a mean of 3.2 and a standard deviation of 1.4697. Let's write that in. So the sampling distribution, let me go back there one more time to show you. The mean is 3.2 and the standard deviation 1.469, 146. So what is this called right here? The distribution. We end up with a mean of the distribution of 3.2 and the standard deviation of the distribution 1.47. That's what we ended up with when you look at this here, 1.47. You got it, okay? And so what's going on here is we just conducted samples, and when we did just samples of size equals 5 of the population, notice the mean actually equals the population mean. So that's why we're allowed to kind of use it as an estimate. Samples are used. The standard deviation is not as close, and so something's happening there. So when we did this in this case, we calculated the mean of the samples to be 3.2 and the standard deviation of the samples to be 1.47. What we really are interested in, let's do this 1,000 times. That should give us a good pattern, and let's use a sample size of 10. So let's go ahead and do that on StatCrunch. Let's reset this. And I want to do 1,000 samples of size 10, and let's see what happens to the sample means when we do that 1,000 times. There it is. Boom, done. And so as it is computed here, you can see we get a mean of 3.2 and a standard deviation of 0.53. And so on this case, and notice the distribution, when we did 1,000 samples here, we end up with a nice normal curve here, or approximately normal curve that's kind of closer together compared. It's not as spread out as this data. Notice the values are closer together than these here. And you can see that has a smaller standard deviation, 1.6 versus 0.53. And so again, when we do this here, we get a mean of the distribution. This is for 1,000 samples. You get a mean of 3.2 and the standard deviation of the distribution of 0.53. I think that's what it is. Let's see. 0.53. You got it. It's definitely smaller because they're closer together. And so that leads us to kind of some other conclusions we'll talk about on the next page. So that's part one.